Algebra, Unit 10, Lesson 2, Notes 2, Graphing Parabolas Without an Interval. To find the axis of symmetry algebraically, identify a, b, and c in the quadratic function, and then substitute in the needed values into the formula x equals negative b over 2a. Now, the negative b doesn't mean you just make it negative. The negative symbol really means the opposite. So we really should read it opposite of b over 2a. So if b is 3, for example, you would put negative 3. If b is negative 2, you would put negative 2, or in other words, positive 2. So it just means the opposite of your b value, okay? Identify the a, b, and c, and then find the axis of symmetry. So here in letter A, our a value is 2, our b value is negative 4, and our c value is positive 7. Remember, your function must be in standard form to figure this out. Okay, the axis of symmetry equation is x equals negative b over 2a. X equals negative, b is negative 4, over 2 times a is 2. Simplify this. Negative 4 means positive 4, and 2 times 2 is positive 4. So your axis of symmetry is x equals 1. So that means when you have your parabola drawn, this axis of symmetry is going to be on the line x equals 1. Let's take a look at letter B. So we have our a value, our b value, and our c value. Remember, it's ax squared plus bx plus c. I have the x squared term. I have the c term, meaning no x, which means I am missing this term. So let's put in what we know. The coefficient here of x squared is 1, so a is 1. And our c value would be the 6. Because I don't have that middle term, that bx, your b is 0. Your axis of symmetry is x equals negative b over 2a. X equals negative b is 0 over 2 times 1. You can't have negative 0, so it's just 0 over 2, and 0 divided by 2 is 0. See if you can figure out C and D. Remember, you must be in standard form first. So to find the turning point or vertex of a parabola algebraically, you find the axis of symmetry, and remember that's your x value of your vertex. So all you then have to do is take that x value, plug it in, and see what the y value is. So find the turning point of the above examples. So these 4 examples are from above. Okay, so I'm going to do A and B because we already found those together. Our axis of symmetry for A is x equals 1. Okay, so all we need to do is we now take that x value and plug it in. And again, that x value of 1 is coming from the above example A. Y equals 2 times 1 squared. 1 squared is 1. Minus 4 times 1 is 4, plus 7. 2 minus 4 plus 7. 2 minus 4 is negative 2, plus 7 is 5. So my axis of symmetry is, the axis of symmetry is x equals 1. The vertex is 1, 5. On letter B, we had an axis of symmetry of 0. So again, look up above. Our axis of symmetry was 0. So I'm going to take that x equals 0 and plug it in down here. Y equals 0 squared plus 6. 0 squared is 0. plus 6 is 6. So your axis, I did it again, your vertex is 0, 6. Go ahead and finish off C and D. I will tell you that C on both of them, you're going to get fractions. So leave it in fraction form. Just a quick note, if your A value, remember ax squared, so if the coefficient of your x squared is positive, the vertex is a minimum point. So this is just a review from 10.1. And if your A value is negative, your vertex is a maximum point. To graph a quadratic function without an interval, follow the steps below. Find the axis of symmetry, find the vertex, then create a table of values. Choose 3 x values above and below the turning point. Graph and label the parabola. Be sure to include arrows on both ends unless it's a word problem in which they are not needed. And the word problem, it really depends on the type of word problem you're talking about. Graph the following quadratic equations by first finding the axis of symmetry and vertex. Your first instinct might be to go right to your calculator, type it in the y equals, and I understand that. However, this question wants us to find the axis of symmetry and vertex by hand. So we must do that. Make sure you leave yourself some room. Our equation is y equals x squared minus 4x plus 1. It's in standard form, so there are your a, b, and c values. The axis of symmetry formula is x equals negative b over 2a. X equals, well, negative 4 over 2 times 1. Negative 4 is just positive 4 over 2. So the axis of symmetry is x equals 2. Now for the vertex, we take that x value and plug it into our equation. So y equals x squared minus 4x plus 1. We're plugging in 2. Y equals 2 squared minus 4 times 2 plus 1. 2 squared is 4, minus 8 plus 1. 4 minus 8 is negative 4, plus 1 is negative 3, making our vertex as 2, negative 3. It then states in our directions that we need to create a table of values by choosing 3 x values above and 3 x values below the turning point. The turning point is at 2, negative 3. So if I were to make a table of values, and let's say I had 2 here, so it goes 1, 0, negative 1, and 3, 4, 5. You can sit here and you can plug in your table of values, but at this point, I'm going to tell you to just go to your y equals, plug in your equation, x squared minus 4x plus 1, and look at your table of values. So we have, at negative 1, we have 6, 1, negative 2, negative 3, negative 2, 1, and 6. Notice how in your calculator, that's where you have that, again, I call it the rainbow effect. It's not a mathematical term. It's just the best thing I can use to describe it. So you have that effect here, which is exactly what you want when you're graphing parabolas with no interval. So you go over to your graph. Let's plot the values we can. Negative 1, 6. 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, 4, 1, and 5, 6. As best as you can, draw your parabola. Now we weren't given a specific interval, so we definitely want to put arrows on it. Okay. There's, again, no interval, so it needs arrows. And let's just make sure we have everything we need. It says to graph the quadratic functions by first finding the axis of symmetry and vertex. So we graphed it, we have the axis of symmetry, and we have the vertex, which means we are done. Try letter B on your own.